This conference will now be recorded.
Okay, yeah. So let's start with the basic terminology. I'll see if we can differentiate this with our net scaler also. So, so first of all, nodes. Okay, so what are the nodes basically? Nodes are the server which basically hosts all the services. For example, let me get my drawing tool. Okay, so these are my nodes. So nodes consist of one or multiple services which basically serves to the original request. Okay, so all the server like a server can host multiple services, like it is acting as a DNS, it is acting as a DSCP, it is acting as a IIS web server, right? But at a time it can like as per the request it will respond to that request. So nodes are simply the server which hosts basically your service. Okay, then what next? We have virtual server. I would say VS. Okay, so in F5 world, uh, what F5 does is it basically all the requests lands on the virtual server. Okay, it's kind of it works as a proxy. Okay, so all the requests, let's say if I have a client here which is having 10.10.1.0 IP and sends a request to get HTTP service from one of the server. But if we have a virtual server, I mean F5 in between, it doesn't send the request to the direct to the server. Where it sends, it sends the request to the virtual server. So let's, for example, I'm taking a virtual server as let's take an IP 192.168.1 dot, sorry, we have 10.10.50. Okay, so in this case, now all the connection which tends to go to a service, let me give a name, let's say my tele.com. Okay, so if a server if a client request comes to the tele.com, first of all, this is user friendly name, so in background it will have a IP. So DNS resolves that IP name into the IP with 192.168.10.50, which means your request will land up to the virtual server. Okay, behind virtual server we will have a term called pool. Okay, so what is pool basically? Pool is IP plus port. Okay, similarly, what is virtual server basically? It's a simply a IP plus port. So IP, which means where your request is going to land and which service is going to access, defined by the port, right? So in pool, so this is my front facing IP, which client request will land. Now in backend, what we have is pool. Okay, a pool consists of one or more servers. So there could be like in my pool I can have 3 IP. Okay, 172.16.1.1. So 172.16.1.1 plus my port number is 80. Similarly, sorry, not 1.1, it's 11, 1.12 plus port is 80. So I'll have 3 server in my pool. Okay, and node only consists the IP. Okay, this is so now as per my why we need a pool basically by help of pool only. So if I have 3 server in my pool, one dot, let me write 13. So by help of pool, I can do the load balancing. So whatever policy of load balancing, whatever method of load balancing you are applying, that will be applied over the pool. So which means once request lands on the virtual server, it sends to the pool. Now, if pool says do round robin, okay, then it looked at the number of nodes in it. So it has 3 nodes, so it should starts from this node and then next node, next. So whatever policy you apply for the load balancing, that applies over the pool. Okay, pool also does a term called monitor. Okay, so we talk about the monitor in brief earlier. Okay, but in detail, so for example, I got the request and one of the server is not available at the moment. Let's say this server is not available, then user might not get the response back if there is no monitor, or the request lands on the server and it is not delivering the services, which means ultimately user will get affected. Okay, so it is very important to have a monitor in place. Okay, and monitor your backend servers. So monitor is the term which is basically monitors your backend servers in a periodic way. So it basically sends it depends on what kind of monitor you have enabled. Way, let's say if it is ICMP, then it just sends a ICMP request and expect to receive a ICMP reply. If a reply doesn't receive, it basically declares the server down. Okay, similarly, if I'm monitoring a services, let's say this server is hosting a web service on port number 80, so I'll be sending a HTTP GET request. So monitor will send a HTTP GET request and it sends a response back. Okay, so once response is received, it mark it as a green. So there will be an icon in front of server. It will be a green or red. So green means it is healthy. If it is red, then it is down, right? So if all the servers are down in a pool, which means ultimately your virtual server is down. Okay, so virtual server will remain up until unless a single server is up in that pool. Okay,
Where this
now
virtual server is configured, Kumar bhai?
where the virtual server is configured, right?
Yes, yes.
It's an F5.
F5,
So,
okay.
yeah, so virtual server is not exactly a server, it's a term, but it's just an IP where your all the request lands from the client.
So a virtual server is the F5.
Yes. So for each services, you can have a single virtual server. It's not like you are having a single virtual server for multiple services. For example, I'm hosting a FTP
Mm,
and web server, right?
right.
I cannot have same virtual server for both the services, right?
Okay.
So each service should have a different virtual server or unique virtual server. Like if I type, if I go here, 1 second. So
So
if
Kumar bhai,
I,
before F5 is there's a DNS server.
yes. So if I type, let's say google.com. So what is my request? Sending data to the google.com. But google.com is my user-friendly name,
Yes.
and first it resolves the IP to the, so you can see here google.com is 216.58.196.1110, right? So first it resolves the IP and then sends the request, right?
Okay.
Now I'm getting the ping response. Okay, but the thing is Google, there might be billions of people are accessing Google at the same time, right? So this is not the
Yes.
true IP of Google, right? I mean, the
Right.
server which is hosting the google.com is not a single server. There could be 100 servers, right?
Yes.
So why I get every time single IP? Because I'm hitting the virtual server.
Okay.
Okay. So once virtual server finds the valid connection, it sends to the backend server. So basically, on behalf of uh, servers, your F5 hosts the services for client point of view.
So we
For
called
that
F5 as a
also,
virtual server also.
yes. So
Okay.
it's a
Kunal
kind of,
Bhaskar here.
yeah.
Yeah. Can you open that talent session? So, whatever the
Yeah.
response we receive from Google.com is the virtual server IP address or a node IP,
No, we get it from virtual server IP.
virtual IP. So, if multiple users can see, yeah, if I'm trying from different connections, the IP will keep on varying, right? Not a sticky one.
IP.
Google.com not going to the same one. So they have multiple virtual server for the same IP. I mean, same FQL, FQDN.
Yes, there could be multiple IP. Depends on, again, that comes in advanced load balancing, where
Hmm?
we can host the DNS on the F5 itself. That is called GSLB, Global Server Load Balancing. Okay, so
Yeah.
what that feature provides is, like, you are in Bangalore, I'm in Delhi. Okay, so it identifies the geolocation of the user. So if I'm the Delhi person, I'll hit the nearest F5. If you are the Bangalore person, you will hit the nearest F5. Likewise, if any person is sitting in uh, your USA, it is not going to come all the way down to the India and then access the Google services, right?
No,
So
no, my only part is like, I mean, what we receive is the server, the virtual server IP address or the node IP address. That's what that is.
no, we always receives the virtual server IP. I'll tell you the scenario where we can get the actual server IP, but that
Uh,
is kind of a condition. I mean, when you need a kind of debugging or you need to see what is wrong in your network and you want to skip F5, then possibly we can see the node IP. But in a true load balancing environment, you will always get the virtual server IP.
okay,
A user never knows about the backend services. For a user, everything is a virtual server.
okay. My second question is like, you said like, we talked about pool, right? The pool members will
Yeah.
coincide with the IP plus port number, right?
Yes.
So if the server is running with the different services, whether I can add that different services in the same pool, or we have to create a different.
No. So all the member in a pool must have must provide the same services. It's like so. I'll tell you why. Because, for example, let me grab a pen. Yeah. So, for example, this is my web server. This is my web server, and you want to add a FTP server in it, right? What will happen? So, and also, I am monitoring with the ICMP, not with the actual service number or port number. So if I'm not monitoring with the port number 80, what will happen? For pool, every server is up, right? So if my round robin method says the first client will go to the server green, second will go to the blue, third will go to the red. So if a HTTP service comes to the server red, what happens? It only knows the FTP port number. There is no service running like HTTP, so it drops the connection, right?
Yeah.
So second point, if we have a monitoring in place with port number 80, so I'm monitoring port number 80, so this server will be already dead. So as soon as I add the port, server in a pool, and my monitoring is placed with the monitoring of port number 80, the red server will not respond with the port number 80. So which means this pool will declare it as a dead server. So service will not be sent to the, or any request will not will be sent to the server. So two conditions.
Yeah.
If you don't have monitoring in
Okay.
place,
So,
then all the requests will die. If you have monitoring in place, then the server will be declared as dead. Right?
so in that case, so all the pool members has to be run with the same services, right? So I mean, this to be added with the same service.
Exactly. So every pool member must have the same services. You cannot. So basically, there is no load balancing if you don't have the same services on multiple servers, right? It's quite simple. Okay.
Okay. What about in this case, like if you have a virtual server with a different port number and the pool member with a different port number, will it be acceptable in this case?
Yes, because your services are different. No? That will differ the. The connection will be different. That can be done even in some environment. We can see, for example, I'm hosting two kind of services. You must be aware HTTP and HTTPS. Okay. Now, what I want, let's say this is my internal network, and there is someone sitting on cloud or over the internet, which is my external network. Okay, and I'm hosting a web server with where I want my internal network member access that web server with the HTTP, and external member must use HTTPS to access the services. But I want the same IP to have that. DNS must resolve with the same IP, right? So that can be possible, but in that scenario, you will have to create two different virtual server. It's not like single server. So IP will remain same, but a virtual server, as I said, is consist of IP plus your port, right? So in this scenario, the virtual server which is hosting HTTP will have port number 80, and virtual server which is hosting HTTPS will have port number 443. Okay, so whenever a request comes in and lands to the port number 80, which
No,
means, yeah, tell me.
no, no, I can understand that. So my part is like, my point is, but the part, I mean, my point is like, whether that between them. See, I don't want all the users. See, there's some kind of security which is always provided in over the web browsers. So like the users want to get access to the HTTPS, but internally they can access to HTTP. So it means like whoever access that HTTP with the port number HTTPS will be redirected to HTTP
Yeah, that's a different scenario.
with a
We
single.
can
I mean, a single method.
sorry, your voice was breaking. Can you repeat your question?
Yeah. So I have only one option. So I have only one VS which is enabled with which is enabled with 443. Okay. But
Correct.
I have a members which can respond. I mean, I have a nodes which I have a servers which can respond back to that query on port number 80. Okay. So all internal users can directly can access 80. Whenever the users from external they come and hit the VIP IP on port number 443, it has to be redirected to port number 80. I
Okay,
don't want to
so
use the two virtual servers for 80 or 443. All has to go through one virtual server. Will it be possible?
yes, possible. It is possible. So you are saying that you need to redirect it. So in that case, you need to add a profile here, which I was about to talk about later.
No.
So it is possible where your F5 reads the your HTTP header. It's without it's a simple when your F5 is just doing load balancing. It receives the request and send it to the backend server. But if you need additional services like you want to redirect request, or you want to read and block, or read and pass, and read and load balancing in an intelligent way to where to land that particular string based communication. So for example, I'm hosting a single web server, single virtual server, but with multiple ports, right? So in my scenario, let's say this server is working on 1007 number port. This is a different service, 1008 and 9, something like that. So uh, in F5 we can also learn a read. We can set F5 in a way like it can read the HTTP header, and as per the header, what is the request and port number, it redirects to the different services. For example, this is my uh, this is for oil plant, this is for management or something like that. So these services can be redirected accordingly. So it receives the string. So we basically all add all the scripts, like if you receive such a string, redirect it to the this server, redirect it to this server. So that can be possible as well. Okay.
Okay.
All right. So let me see. So we talk about virtual server, pool, monitor. Yeah, I was talking about profile, self IP. Okay. So now let me remove this, or let's keep it in this way. So I'm keeping it all. Okay. So now Okay, so now we'll talk about self IP. Okay, so now for now, so far we have virtual IP, sorry, virtual server. Okay, down the line we have pool, and then we have node. And here we have in between we have monitors, and load balancing method. So that is on pool. Now what is self IP? So in many times we have talked about how the connection are formed between client to F5 and F5 to backend servers, right? So for example, if I say we have a client and F5 and then a backend server. Client, instead of F5, I'll say this is okay. This is my virtual server, and this is node. Okay, so how basically the connections are formed? Since SYN F5 sends on behalf of server, it sends SYNEC, and then so once connection is established till your virtual server, then it initiates the backend connection, which is, so this is called client, this is called client side connection, and this is called server side connection. So same process will be done once your connection is established. So sometime you can say that F5 also provides you the security from DDoS attacks. So suppose peoples are want to access your all resources. Sometime it may happen that they are sending TCP SYN, and your connection is full, right? So TCP SYN attack is a kind of attack also. So what F5 does, it doesn't forward any request to the server until unless your TCP three-way handshake is completed. So this is SYN ACK from node to the back to the virtual server, and back ACK. So in F5 we have a component called a virtual server, and there is another layer which is called self IP. So basically when you compare two sessions, then you will see client request establish the connection with the virtual server, and self IP establish the connection with node. Okay, so there are two separate IP now. So in my example last time, we have assigned IP to the virtual server is 192.168.10.50. Okay, now so we must have another IP which communicates with the backend server. So we'll have somewhere here I'll have a self IP. Let's say 172.16. Sorry, let me 16.1. Let's take it 1 dot 50. Sorry for writing. Okay. Yeah. So all the connection for again from client 1, if connection comes to the my service, it will hit the virtual server. And what virtual server does, sorry, your F5 does, it establishes another connection from your self IP to the node. Okay. So self IP, every F5 or every service will be redirected to the backend server via self IP, and every F5 will have a unique self IP. So for example, if I'm running 5 F5, then every F5 will have self IP. For example, this has 1.50 and this has 1.51. If I have another one, that will have another one. So all the F5 will have a self IP to establish connection to the backend servers. Okay. Now, and this process.
तो
Yes.
एक क्वेश्चन था सेल्फ आईपी कितने सेपरेट जैसे एक सपोज अपना F5 है F5 पे नीचे अपने 3 अपने रूल लगे हुए हैं क्या तरह से सर्वर लगे हुए हैं या नोड तो वो सेल्फ आईपी एक रहेगा या सब नोड के लिए अलग-अलग सेल्फ आईपी होगा जैसे
Single.
My friend, can you ask in English so I can understand? So I don't know.
Okay. So yeah, there will be a single self IP. Okay. Second point, what if I have a server which doesn't exist in this server? I mean this subnet, right? For example, I have a server here which has IP of 10.50.1.1. Okay. In this scenario, what you can do is create a static root in F5. Okay. And for 10.50.1.0, whatever subnet is 24, and send it to the gateway of self IP 172.16.1.1, for example, right? So even though you have a server which is not in subnet of your self IP, you can redirect requests with this way. So you basically self IP will be the source of the request, send it to the gateway, and gateway again pass it to the original servers. Okay.
Kunal, you stated like a static IP to static route to be created pointing to self IP. Is that to be done on the server? Yeah. Is that to be done on the server or on F5?
F5.
F5. Okay.
So in F5, yeah. So basically
how
the
come
motto is
that different subnet will be intercommunicated?
How come this different subnet will be?
I mean, exchange the packets between the different subnets.
Okay, it's basic
See,
routing.
suppose whatever you say, like we have created a static with 10 dot subnet, and the default gateway is 172 seconds. So how come
Yes.
this can be little bit complicated? So if you don't have any kind of routing portion.
Now we do have routing. Backend, if you see my topology, if I self IP has 1.50 and connected to a core switch where my both the subnets are connected. So for example, this connected, this is VLAN 10 and this is 20, VLAN 20. So I'll have gateway on my core switch, right? Now, if I add here, my F5 is also on VLAN 10, but if F5 wants to reach VLAN 20, what we'll do? We'll send the request, via static route, I'll send the request to the VLAN 10 gateway, which is 172.16.1.1. Then the routing part will be taken care by the core switch. So request comes from F5 to the gateway of VLAN 10, redirected to the connected subnet to VLAN 20, and then return is same again. It comes to the core and then goes to the F5. Right. So why we always need a self IP to redirect the request? To establish the connection with the backend server. There is a logic on it. It's simple. So for example, let me erase it. Yeah. So for example, as I said, we have virtual server. Now I'll add another here is self IP. Okay. So virtual server to self IP to your node. Okay. Pool comes before that, because once pool decides that which node it is going to send, then self IP change the source. So all the communication established to the virtual server from client, and then pool decide which nodes to hit as per the load balancing method, and then it changes, F5 changes the communication source and destination IP from self IP to node IP. Okay. What if I don't have a self IP in communication? Okay, which means communication going to come to the virtual server and sending same source. For example, 10.10.1.0. Sorry, let me give you IP. Client IP is 1.10. Destination IP is 192.168.10.50. So this is my virtual server, VS. Okay, and sending it back to node. Node is going to 172.16.1.11. So this is my forwarding traffic or request. What? And now I'm sending a response. Okay, so IP will be 172.16.1.11. Send it to the gateway, which is, sorry, this is 11, which is my 1.1. But now when request lands to the your switch, it knows route via this way. It is not going to the F5. So which means it has the route to reach 10.10.1.0 via this subnet or router. So this is a challenge, which means it is creating a asymmetric routing. Okay, and request lands up to the server with source IP of client, and then it sends the request as per the routing. So your F5 is not going to come in between for return traffic, and that creates a asymmetric routing. And maybe there are a device in between which doesn't allow asymmetric routing, like firewall and other stuff, which basically stateful, which counts every session to be established with the same IP. So in that scenario, your request will be dropped, or might be got redirected to the other way. So that's why we need a self IP. So whatever connection initiated by client tends to the big IP or your F5, and then F5 creates another session, self IP.
One by I
So
didn't understand this.
okay. So if we don't have if we don't have self IP, okay, let me ask you one question. So when a request comes from client to the virtual server, what will be the source IP?
The for the virtual server, the 10.10.1.10, yeah,
1.10. This is
1.10,
my
yes,
source, right? This is my
yes,
source.
yes,
While receiving requests on the virtual IP,
virtual IP.
sorry, virtual server. So if I don't have self IP, which means F5 will not change the source IP, that will go as it is. Okay.
Right,
So
right.
service got hit, and source IP is still 1.10.
10, yes,
Now, if server receives a request with source IP 1.10, it might have different route to reach this subnet, because F5 is not inline here.
right.
F5 is not inline, which means it doesn't exist between router and switch. So what response? How response will travel? It will go to the switch and directly go via the router back to the client. So this is
Okay,
creating asymmetry, right? So going route, forwarding route is like this, here to here, and then back to the server. So return route should be like core switch to the F5, F5 to back to the switch, and then back to router. Should be like that, right?
mm-hmm.
So if we talk about the symmetric routing, if my request is going to via F5, then return should go via F5 as well, right? But if we don't have self IP, it won't go via
Same route.
F5. Yeah. So if we have self IP, the server knows that request came from F5. So it sends a reply back to the self IP, which is my 172.16.1.50. So now F5 has two IP, 192.168.10.50, which is my virtual server, and F5 have another IP, which is 172.16.1.50.
50.
Yeah. So what happens? Client request coming to the 10.50, changing it to the 172.16.1.50 as a source. So client IP has got changed to the source IP of server. F5. This is my self IP, and now sending it to the server, which means server will know that for a response I need to send traffic back to the
Self IP.
1.50, which means it is landing back to the F5. Now F5 knows, okay, 1.50 request I need to send it back to the
1.10.
1.10. And this process, just this process So how F5 calculates all the request response, because every request is coming via a separate source and going to the separate service. All this record is called AutoMap. Just a new term, AutoMap. Okay. So basically, like you know about the net translation, netting, you know. So if I'm establishing a NAT connection, it will have the information about the source IP, destination IP, source port, destination port, and again it will convert that IP to the different IP, and then it will keep the record.
Netting, right?
Yeah. So similarly, F5 creates the record with feature called AutoMap. Okay. So AutoMap keeps all the information about the which source came with which request, and where the self IP has sent it to backend server and return traffic should go via the same way. So sending back
Catch.
the request, yeah. So sending back the request, again it will change IP to the virtual server and send it to the client.
So
So how
AutoMap
many
is
self
configured.
IPs can be created, my friend?
Sorry.
How many self IP can be created for the F5?
Self IP is
Self
only the one.
IP, again self IP is unique and only single IP.
One single IP. If you have multiple subnet, we can have the single IP in this case, or
Yeah.
we can have based on the subnet we have to get.
So if you have multiple subnet, then you need to have static.
Static route.
Okay.
So Kumar bhai,
So
AutoMap is configured over F5.
yes.
Okay.
So it is configured by default. You need to see it. You need to double check it. If it is disabled, then it will create the same scenario where client IP will directly land to the server. It doesn't change it. Right.
Okay.
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 In certain case, if some pool member got failed, in that case, how does the AutoMap will go?
You say in pool
Or the
member.
client already established a connection with the the 10.1.10 been established a connection with the 172.16.1.11. Okay. So
Okay.
by certainly some unfortunately that connection, the server gone down. So
Yeah.
in this case, if again the second connection has to go through with the 1.13, then how does the AutoMap will be
So
act in that period?
in in this scenario, what happens, like pool member has got down, right?
Hmm.
So the pool declares the server down. On behalf of your service, your F5 will send a reset, TCP reset connection to the client. Okay, then it establishes the new connection with the different server.
Okay.
Okay.
Okay, because if the AutoMap is been enabled, so it will keep on it should not keep on trying with the same server.
Yes, exactly. So if server is down, then again your self IP comes after the pool. So if pool decides that this connection is this server is down, then self IP will not be able to send any request to the your backend server, because pool doesn't send any request to the backend server in that case. Right. All right. So there are few more terms. So any doubts so far? This is kind of interesting, and we must know this. So what we have now? Floating IP. So we talk about self IP, AutoMap, client side connection, server side connection. So let's talk about floating IP. Siraj, you want to leave?
Yes, I have 1, 2, but the class is
Sorry, I didn't know that. I thought of we'll finish by 8:45.
okay.
Okay. So you can leave then. I'll call you. So
Okay, Gaurav.
this is last topic I'm taking up. I'll talk about other terminology tomorrow.
Okay, so
Okay.
floating IP. Okay, 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 Gaurav bhai. I'm leaving now.
Okay.
Okay, thank you.
Yeah. So for floating IP, yeah. So floating IP is nothing like, as you know, we have self IP. So floating IP is again same kind of feature, but if we have two big IP in HA, high availability. So let's say this is my active F5 big IP, and this is my standby. Okay, so it's similarly your HSRP or VRRP we use. So instead of self IP, we can configure floating IP. Okay, so floating IP, again it's a virtual IP which will be binded to the active big IP at a time. So it's a virtual IP. If my this F5 is active at a moment, it will be binded to this one. So all the requests which is going to the backend server will be going by the same IP always, even though my F5 has gone down and new standby F5 has become the active one. So your self IP is not going to change. So we can say this is a virtual IP which is owned by both the F5, but will be associated with the only active one at a time. So all the requests comes to the virtual server, lens to the virtual server will be uh, using floating IP to establish the connection to the backend servers. Okay.
Okay.
Don't mind. Can you repeat me?
Yeah. So floating IP is a virtual IP between a F5 HA pair, and that will be uses for the to the connection establishment with the backend servers. So and at a time it will be associated with the active server only, sorry, active F5 or big IP only. So whoever is the active F5, that will be using the floating IP. Once active become so this active has gone down and standby becomes the active, your IP is going to be same for backend service.
Okay.
So floating, it's kind of, it can be owned by anyone who will be active that point of time. So both instead of having unique IP, both are sharing the same IP. Depends which big IP is active at the moment, right? Again, there is one benefit of having floating IP. For example, if you want to access always active a big IP, you can access your big IP with the floating IP. So whoever is, it doesn't matter which device is active at the moment, it will always land to the active F5, right? So it's kind of similar to HSRP. or VRRP concept that we configure a virtual IP and multiple gateway, but it will be associated with the higher priority or whoever is available gateway at the point.
Okay.
All right, so I still have few more terminology to cover, but we'll do it tomorrow.
Kumar, can we do one thing? We can start class around 7:30, so it will suitable for everyone, I guess. Nobody will leave early,
Yeah,
and we
so
can have class
that's
10
yeah,
to
7. Yeah, we were planning to have 7:45. Is it okay with you, Bhaskar?
Yeah, fine.
So we'll from
7.
7:30 or 7:45.
7:30 is good, I guess, because sometimes classes take time. Nah? Like you are talking
Yeah.
interesting topic, like today. So we
Yes.
don't want to lose
So okay, let's do it at 7:30.
from tomorrow.
Yes.
What about the basket?
Yeah,
Are you
Yeah.
okay
it is
for
done.
7?
I'll convince. I don't have any issues. I can-
Okay. We'll start 7:30 from tomorrow.
Okay.
Kumar, how
Okay,
much?
guys.
So
How
one
much?
more about the lab setup. Can we have
Sorry.
that lab setup for this for us?
Okay. I'll you need how to do Lloyd lab setup, or you need access to lab?
I need access to lab because my PC won't support that.
Okay, so I'll give you a username password with the IP address. You will end up to this lab. Okay. Right now I have not created a specific user ID, so I'll create your user ID on this lab, so you can
Okay.
access this lab. So
Okay.
yeah, I need to import and export this, so that will not take much time. But I'll do it tomorrow, today. Possibly I'll give you access to till afternoon. Okay.
Okay. You just give a overall glance how the things has to go. I mean, how we have to
So,
set up the
so
end.
all these nodes will be in your lab. Uh,
Okay.
you need to configure accordingly, but don't make any changes, because if you make
Okay.
any changes in your lab, that will be in front point of view. But I mean, inside device you can do any changes that is individual to that lab. But
Mhm.
on point of view topology, don't change in that.
Okay.
Okay.
So no, is it possible to create as a new I mean new page or a new something setup where we can build up with the thing? Uh,
Yes,
because
that can be.
just for the practicing session, we wanted a big IP device. So we can log what are the changes are
Yeah,
uploading.
you will get. I mean, you will get the. I mean, you will get all the devices from scratch. So you need to build from scratch. So it's like a
Okay.
new lab for you. But
Oh,
keep the front view as same. So if I delete
oh,
this server, it means it will be
oh,
deleted for everyone,
okay.
right? Just
Okay.
keep that in mind.
Okay.
Otherwise, you
Okay.
can do any changes inside of the server. You can change this subnet, whatever you want. Okay.
Okay.
So
Okay.
inside device,
Understood.
it is individual configuration.
Okay. Okay.
Okay. All right.
Okay. Miss.
Okay. See you tomorrow then.
Thank you.
Okay, 7:30.
Sorry.
7:30 tomorrow.
Yes. 7:30. I'll ping
Bye
you
bye.
on Skype also. We'll sorry on
WhatsApp.
yeah.
WhatsApp on WhatsApp.
Okay.
Okay,
Okay.
guys.
No, and also don't forget to share that document. That document.
Okay. I'll send it right away. Okay.
Okay.